Hello everyone, welcome again in Eng-Man YouTube channel. So in this video, we will continue our learning on oil network modeling. And in previous videos, we have defined the pipeline. Now we will perform the pipeline matching. So it's going to be very an important step within the entire exercise. All right, so it's about pipeline matching. All right, measurements in the field have been provided for the flow line that links manifold A here and manifold B. The intention is to use this data to match the pipeline in the gap so that it will reproduce the measured pressure drop in the field. Okay, and then if you read the data in the if you read the data in the gap manual, the measurement have been provided by field engineers, and you can see the table in the gap manual. And there we have the data, the upstream pressure, the value is 480 psig, and then the upstream temperature 90 degrees, 97 degrees Fahrenheit. And we also know the liquid rate, 17,250 stock temperature per day. And then the downstream pressure, 340 psig, water cut 47%, and gas oil ratio of 800 SCF per STB, oil gravity 37 API, gas specific gravity 0.76, and lastly, we also know water salinity of 23,000 ppm. All right, so to carry out the pipeline matching, we double-click on the pipeline that links manifold A and manifold B to activate the pipe summary screen like this. Okay, so here you can see we have label, name, comments, pipe type. We use gap internal correlation, and the correlation that we use is Petroleum Expert 5 with gravity coefficient and friction coefficient of 1. And then we use system default for bubble point pressure, solution GOR, and oil formation volume factor correlation. And we also have the data for environment and then description of the pipeline. And now we go to matching like this. All right, because we want to match the field data and the predicted value within this segment. So let's populate this table with data. So it's 480, 97 degrees Fahrenheit, 17,250 stock temperature per day, 340, 47, 800, 37, 0.76, 23,000 ppm. All right, quite easy. Now we will match the Petroleum Expert 5 correlation by selecting match and then selecting the correlation from the list of available flow correlations in GAP. Okay, so let's just click on match button there. You can see we have a match button there. Okay, we need to insert the data here. So H2S, CO2, and nitrogen. Let's just input 0 at this segment. Okay, good. At this point, you can also do validation if you want. Data is okay. So now let's press on match. You see for the correlation, we have Baxandril, Gashead, Duckler, Eaton, Flanagan, and down to Petroleum Expert 5. So that's it. We select Petroleum Expert 5, and we can select all or none, but let's just select Petroleum Expert 5 to see whether this correlation can match the field data. Now let's just click on match. Matching is completed. Okay, matching is completed, so it's quick. So the gap model now reproduces the measured field data and can now be used for forecasting and modeling different development scenarios. Okay, so you can click on OK. You can check the statistics, gravity coefficient, friction coefficient, all 1. And we have standard deviation of 0.02782794 for Petroleum Expert 5, which is quite good. Let's see if we include all of them. and then press match. Okay, and then let's check the statistic, but the computation is in progress. Maybe it's going to be quite long, but that's okay. Now, later we will rank the standard deviation of this correlation. Hopefully it doesn't crash. So I think I'm going to pause for a while and then let's see if the matching for all these correlations can be completed. Okay, see you later. Okay, so I think I will change my mind. It took quite some time for this correlation, for this particular correlation. So I think I can cancel, hopefully. All right, and then let's just test the Beksan Brill and then maybe Duns and Rose and then Hagedorn, Mukherjee, and Petrol Maxford 5. Let's check match. Matching is completed, right? Statistics. All right, so let's see. Actually, Duns and Rose modified gives us smaller standard deviation. And then also Fancher and Brown also quite good. And Hagedorn quite good. But that's okay. Let's just follow the manual. And instead, we will select, Petrol Expert 5. But you can see you can also use like Duns and Rose and then Fancher or Fancher Brown because they give us standard deviation quite low, although they include friction coefficient. We can achieve small standard deviation with gravity and fracture coefficients of 1. All right, so yeah, maybe you need more consideration before you can finally select the best correlation. Okay, but for now, let's keep it using, Petronex 5. Click on OK. OK. Once again, here, correlation selection, we use Petronex 5. And in summary, also Petronex 5. All right, so once again, the gap model now reproduces the field data and can now be used for forecasting or modeling different development scenarios. At this point, we can click on OK and then save. The gap model has now been built. After you save, I'm going to stop the video here. In the next video, we will analyze more what we can do with this oil network. And maybe in the next video, we will talk about initializing the IPR from the MBAL file, from the tank simulation. Okay, so I think we can close it here. Thank you so much and see you.